In this lesson, we're going to look at the length of an arc and the area of a sector of a circle. From junior cert, you remember that the full circle 2 pi r is the length of a full circle. I'll change the green one to red. So 2 pi r is the whole distance around. If we just wanted a fraction of that distance, if we wanted this distance here, I'll change it to blue. It's going to obviously be 2 pi r multiplied by theta over 360, where theta is in degrees very importantly. And you can see here this 2 pi, 2 180s is 360. You might have seen this before in Trigonometry 2 when we dealt in radians. So we'd have 360 on top and 360 on the bottom, which would cancel, which would just leave me with this r and this theta. So if you're looking at it in radians, the length of an arc for a fraction of a circle is equal to r times theta, where theta is in radians. So there's two ways to look at it. Both formulas are in the tables. You choose what one to use, and normally you would get a choice because you can convert degrees to radians and radians to degrees. So let's look at the area of a sector. When we're dealing with area, you'll remember from junior cert pi r squared. But if it's a fraction of a circle, it's pi r squared by theta over 360, where theta is in degrees. Again, the difference between degrees and radians. And these formulas are in the formulae booklet. Half r squared theta, because if you see this 180 over 360 is going to be 1 over 2, which is where this 1 over 2 comes from. So a half r squared theta, where theta is in radians, is the area of a sector. So let's look at 3 questions in relation to this. Okay, so 3 questions. Pause the video and try them. Now the angles are in radians here. You can see 0.7, 0.2, and we will need this angle in here. So try and figure out what this angle is based on your radians. Okay, so here's the solution. The area, always write down your formula. The area is equal to a half r squared theta, where theta is in radians. So we have a half by 10 squared by 0.7, which is a half of 100, which is 50, and 70% of 50 is 35 centimeters squared. The length of the arc, very simply, is r theta, which is 10 by 0.7, which is 7 centimeters. When we finish these 3 questions, we're going to look at converting the radian measure into degrees and doing the same questions again using degrees instead of radians. So this one here, area, half r squared theta, a half by 5.2 squared by 0.2, which to 3 decimals is 2.704 cm squared. The arc is r theta, which is 5.2 by 0.2, which is a fifth of 5.2, which is 1.04 centimeters. So question 3, we know that there's 2 pi radians in the full circle. Now you could just change pi to 3.14 here, or 142 maybe, to be a bit more accurate, and then take away the 2, and that will give us the measure in radians of what's left. That'll give us 4.284 for my green angle in here. So the area, half r squared theta, where theta is in radians, is a half by 12 squared by 4.284. So we type this into a calculator. We get 308.44845 centimeters squared. So we have r theta for the length of the arc, which is 12 by 4.284, which is equal to 51.41 centimeters. Okay, let's look at converting these into degrees. So 0.7 radians. What's this in degrees? Well, we know 180 divided by pi is 1 radian. So it's kind of handy to have what 1 radian is as an approximation. So divide 180 by 3.142. You get 57.288. So we'll call it 57.29 degrees. So if that's 1 radian, if we multiply that by 0.7, we'll get what 0.7 radians is in degrees. 40.1 degrees. So if we use our junior cert method to find the area is equal to pi r squared by theta over 360, where theta is in degrees. So we'll have pi by 10 squared by 40.1, and it's a fraction of a circle. What fraction? It's 40 over 360. And because we rounded off here, we get 34.998, which we would obviously round off to 35 centimeters squared, which you can see is what we got up here. And what did we do up here? We got 35 centimeters squared. So the 7, we should get 6.99-ish when we look at the length of the arc here. So the arc length, using your junior cert knowledge, is 2 pi r. That would be the full length multiplied by the fraction of the circle, which is the angle over 360. So 2 by 3.142 by 10 by 40.1 over 360. And you can see here how using radian measure is actually shorter. And we get 6.999. So 7 centimeters. Double check. We got 7 centimeters. Okay, so pause the video and try the next two before seeing the solution. So multiply 0.2, so it's a fifth of a radian, so it's a fifth of 57.29 degrees, rounded off to 2 decimals, which is equal to 11.458. We could round it off to 4.6, but we leave it at 4.58 because we're rounding off anyway. So that's in degrees. So the area is pi r squared by this 11 over 360. So pi by 5.2 squared by 11.458 over 360, which works out to be 2.704 centimeters squared. What did we get up above? Well, we got exactly the same. And we got 1.04 for the second part. So it's 2 pi r for the arc, 2 pi r by theta over 360 because it's a fraction of an arc. So 2 by 5.2 by 3.142 by 11.458 over 360. And we do get 1.04002, so 1.04 centimeters. And the next one then. So we need to take 2 away from our 2 pi in radians. We got 4.284. So we're going to have 4.284 multiplied by 57.29. So let's do a big angle. And we're going to get 245.43 degrees. So my area is pi r squared by theta over 360. So 3.142 if you want by my 12 squared by my 245.43 over 360, which will give us 308.45 centimeters squared. What do we get up above? We got the same. And then the length of the arc is 2 pi r, would be the full one, by theta over 360, which is 2 by 3.142 by my radius of 12 by my angle 245.43 divided by 360. And if we type this into a calculator, we get 51.409, 51.41 centimeters. What do we get up above? 51.41. So here you have arc, sectors, area of a sector, length of an arc, and radian and degrees. It should be an easy enough topic for you to master.